Welcome to Chapter 11, C file processing. So in this chapter, we're going to look at uh, reading, creating, writing to, and reading from files in C. So far, any data that we have stored, we stored in variables. And whether those variables were scalars or arrays, one thing that always happened was that when you end your program, any data, any information you had stored in those variables was lost. And next time you restart the program, anything you had done the last time is forgotten. Files are a means to permanently remember data. Now, there are many different storage media, many devices on which you can store files on a computer. Can be on a hard drive, can be on a mechanical drive, an SSD, a CD, a DVD, flash drive. What the storage medium does not really matter. That is immaterial. So let's look at how files are created first, because you need to create a file before you can write to it, read back from it, or maybe just update an existing file. Now, in this chapter covers both sequential access files and random access files. We will cover sequential access files today. Now, from the perspective of your computer, from the perspective of C, a file is simply a stream of bytes. Think of it as a very long array. And at the end of that stream of bytes is an end of file marker. Or you can also think of it a little bit like the null character at the end of a string. Whenever you open a new file, whenever you open a file, a stream is associated with it. Now, there are three files that always exist on your system, and those three the associated streams are the standard input, standard output, and standard error streams. Standard input by default is connected to the keyboard on your computer. Standard output by default is connected to the screen, your console window. Standard error is oftentimes also connected to your screen. But you can change the input stream from where a certain program is taking its input. You could just as well or just as meaningfully have that come from a file. You could have a program that puts its output into a file. And just like that, it might be more useful to put error messages also in some kind of log file. Streams then provide communication channels between files and the programs that use them. So like I mentioned, the standard input stream reads data from the keyboard. Standard output prints output to the screen. To open a new file, we need a pointer to a structure called a file structure. This is new. And file structures are defined in the standard IO header file. And in some systems, this file structure includes something called a file descriptor, which is an index number, and I'll show you that in a few minutes. An index into an OS operating system array called an open file table. Each element of that array contains something called a file control block that I will talk about a little later. That the OS uses to manage each file. So one block per file that's being managed by the OS. Now, the standard input, standard output, and standard error also have file pointers associated with them, and there's some standard names for them, and they are stdin, stdout, and stderr. Now, the standard IO library has a number of functions that we can use to read data from files and write data to files. Let's talk about file reading functions first. So there's the fgetC function, which gets a character from a file. That's what the F and the C stand for over here. And it is a lot like the getCharacter function that you've already used. The fgetC function reads one character at a time, but from a file. In order to function, of course, fgetC needs to know which file, which means it needs as one of its arguments, as its argument, a file pointer. If you call fgetC and you provided standard in, the standard in file pointer, it'll read one character from the standard input, the keyboard. And if you think about it, that's really just the same thing as calling the getCharacter function. Now, for writing to files, we have the fputC function. And that is a lot like the putCharacter function. Now, it needs two arguments, of course. It needs the file pointer, needs to know where the character has to be written to, and, of course, the character itself. So, using the fputC function looks something like this. Character, the data to write, and the stream, the file where to write it to. And this is a lot like using the putCharacter function for printing a character to screen. And these are not the only functions. There are, for example, as you can see, these functions work character by character. That can be fairly slow. One function called per character access. More efficient functions, maybe for an application, maybe the fgetS and fputS functions. The S here stands for string. And you can use these functions not just to read a token or write a token to a file, but you can read and write an entire line to a file. So if in an application it makes sense to use the fgets, fputs functions, using them will be more efficient than accessing files character by character. And just like we have the scanf and printf functions we have the ones that we've been using so far. There are file equivalents of these two functions. Scanf's file equivalent is fscanf. Printf's equivalent is the fprintf function. They work exactly the same way, with the addition of taking a file pointer as an additional argument. Remember, scanf takes its input from standard input, printf prints the formatted output to standard output. So the file pointers are implicit in those functions. Now, as for the contents of files, C by itself does not impose any restrictions, any structure on the contents of a file. That is really up to you if you're creating a file. So C does not talk about contents of files in terms of records. If you want to write a record, you have to figure out what the structure of that record is going to be. And we're going to look at a simple example in here, in which we perform simple sequential access to a file that shows how you might maintain information about accounts in the system, and how you can keep track of the amounts that different companies owe you. Each client, in this case, so this is now the structure of each record that we'll write into this file. Each record will consist of an account number, kind of like a client number, the client's name, and the owed balance by the client. Together, these three fields will constitute one record for one client. And here's the sample code for that. So we begin by defining a file pointer, and this is new. File has to be put in all caps, in all capital letters. CFPTR over here stands for client file, PTR because this is a pointer. In the following line, we first attempt to open the file using the fopen function. The fopen function takes two arguments: the name of the file, so in our case we're calling it client.txt. I think in some other, later on in the slides, sometimes in some places it's referred to, it's called, I think, client.dat, dat short for data. And the second argument specifies what type of access we want to perform on this file. A W means write access, meaning we're going to write to the file. Now, fopen returns a file pointer, which we're going to store in CF pointer. If for some reason it is not possible to open this file for writing, for whatever reason, the value returned by fopen will be null. And that's what we're checking in this if condition. If the file pointer returned by fopen is null, means we couldn't open the file. And that's when we go into the if block and print out file could not be opened, and that's it. We're out of the program. If we're able to open the file, we go into, if this if condition doesn't become true, if the file pointer returned is not null, we enter the else block. And that is where all the interesting part, where the actual program is. Here, let me just show you that if This is the end of the else block. So if we're unable to open the file, we're really jumping right here to the end of the program. And what happens if we are able to open the file? We print out a message, enter the account, name, and balance. And we also give an additional line of instructions saying that if you enter end of file to the input, that'll end the program. And after that, on another line, we print out a question mark followed by a space. This will be kind of like a prompt telling us that this is where we have to give input. You can make that anything. You'll see what this looks like when I run the code in the hands-on section. And then we define an unsigned integer called account, a character array of size 30 called name, and a double precision floating point number called balance. And then we call the scanf function. And the scanf function reads in the account ID, account number, name, and balance. And remember, out of these three, name will not have an ampersand sign because name is an array. So the ampersand sign is not needed over here. So we read in these three. We limit the size of the string that is read into name to 29. And then we have a while loop over here because we may want to enter multiple accounts into this file. And the while condition for entering and continuing this loop is to check if what we have received from the standard input is or it is not an end of file character. If it's not an end of file character, we call the fprintf function. Now, the fprintf function, like I had said a few minutes ago, works exactly the same way as the printf function, with one addition. It takes as first argument a file pointer. The file pointer to the file into which you wish to write what the printf function would print to screen. In this case, we are printing account number, name, string, and balance. We're writing those into the file. With that completed, we print out another prompt line asking the user to enter the next record for the file. And we read that in using the scanf function again. And that'll take us back up into the while loop condition. And if the input was not an end of file character, we continue to write that to file using the fprintf function, print out another prompt, and wait for the next record from the user. After the user inputs an end of file character and we jump out of the while loop, we close the file using a call to the fclose function. And this takes as argument, of course, the file pointer. It needs to know which file we're closing. And here's a sample run of what that can look like on a system. So we print out one message, two messages, and the prompt, a question mark. You can use anything you like over here. And what you see, all the bolded text is the input given by the user. So account number 100, Jones, and this is the remaining balance, 24.98. Next entry is 200, account number 200, Doe, 345.67, and so on, until you're done with the last record. And when prompted for a record again, you hit end of file, which is on Linux, Control+D, and on Windows, Control plus Z, followed by the Enter key. Now the following slides just explain this code pretty much line by line, but there are some additional things I want to show you. So you can see that the records are in a fixed order. Account number, followed by name, followed by the amount. That format for keeping records in the file is decided by you, the programmer. In a sense, that is like a very simplistic file format. When you want to read this file, which we're not doing in this example, but when you want to read this file, you have to know in which order the data has been written into the file in order to retrieve it. So like I said, CF pointer is a pointer to a file structure. And for every file that you open for reading, writing, appending, or whatever type of access, you have to create a separate file pointer. Now you do not need to know, you already know about structures, of course, but you do not need to worry about what everything is in that structure. But you need to remember to include standard IO.h if you're going to do file accesses. Some of the data in the file structure is used in the file control block, the FCB, that the operating system uses. Now, in our case, file name was, I think, client.txt in the code. Over here, it refers to the same file as client.dat. Doesn't really matter what you call it, so that's perfectly fine. You can give it any name. fopen, we just saw, takes two arguments. The file name, that's number 1, of course, and number 2 is the file opening mode. In the example that we just used, we opened the file for writing. And so the second argument, the file open mode, was a string containing W, not a character, a string. What that does is it will, if a file does not already exist, it will create one and open it for writing. There are also other modes that I'll show you, but that's what the W mode that we used did. The if statement that we saw ensures that the file was actually opened by checking if CF pointer is not null. If it is null, that means print that error message and exit program. Otherwise, the actual program, proceeds to taking input from the user. And we saw that the program prompts the user to enter each field of one record at a time, or to enter end of file character, Control Z in the case of Windows. The end of file character is basically used to signal to the program that there's no more data to be processed. And like I said, this is something that is OS dependent. We also saw the use of the EOF function. And the argument that we gave it was the pointer to the file being tested for end of file indicators, stdin in this case. Now the function returns a non-zero or true value when the end of file indicator has been set. Otherwise, the function returns 0. And the while loop continues for as long as the FUF call returns continues for as long as the FUF call in the program continues executing. Yeah. Now we're not reading data in this particular example. That we'll do in the next example, in the next section. The fprintf function doesn't require much explanation. It's basically the same format as printf functions with the addition of this one first argument specifying into which file the formatted output, the next second argument, should be printed. Now you could also use the fprintf function to print your output to your standard output, which is usually the screen, by simply replacing the file pointer over here with stdout. And finally, when you're done doing everything, when you're done working on your file, or done writing to your file, I should say, you close it using a call to the fclose function and passing it as argument the file pointer. Now, since we're not reading the records back from the file, in order to make sure that the program actually ran, what we will do is, after we run the entire program, we'll open the file that we wrote. We'll open it in a text editor and we'll check if the contents of the file match what we put in at the command line. Now just a few more details about the file control block that I talked about. So like I said, this is a file system structure that maintains the status of an open file. The FCB, the file control block, is managed by the OS, but it is not kept in memory occupied or used by the OS. It is kept in memory, in the memory of the program that is using the file. So this is a little bit how accessing a file, how that happens. So you call fopen for a certain file, let's say the clients.dat file that we just had. We want to open it for writing, and we store the file pointer in CF pointer. That's what we just did. What that does is, it will, in the file, in the structure behind CF pointer, it will contain an index number. In this case, let's say that index number happens to be 7. That number can be used to access the open file table maintained by the operating system. And so 7 means that entry number 7 in the open file table refers to the clients.dat file that we're using in our program. Okay, now I mentioned that there are many other modes for accessing files. Here's a whole bunch of them. There are further variations of these modes. But these are like the basic ones you need to know. So we used W for write mode. What it does is it creates a file for writing, and if the file already exists, it will delete the pre-existing file. If the file does not exist already, It makes a new one, which is what we're doing. Then we have the read mode. The read mode opens a file only for reading, meaning you cannot use printf into that file. It'll read the file from the start, and if the file does not already exist and you're trying to read it, that will of course be a problem. We can also open a file for append action, meaning a file, if the file already exists, it will write to the end of that file. And if the file does not already exist, it'll create a new one. Then there's a read extended mode, which allows you to open a file for reading and writing, both. Reading begins from the start, but if the file does not already exist, you get an error. And the string for that, for the second argument of fopen is r+. Then we have the write extended mode, w+. This one creates a file for reading and writing. Whatever is already in the file, if it already exists, is destroyed, deleted. And if the file doesn't already exist, it'll make it, it'll create it. And then we have append extended, a+. Also opens a file for reading or writing. Writes to the end, it's an append mode after all. And if the file doesn't already exist, it'll create a new one. Now, files can sometimes also be opened by multiple programs, especially if we're talking about read access. If you want to have exclusive write access, want to make sure that your program is the only one writing to that file at one time, you can add an X at the end of W+, or any of the other modes to make sure that your program has exclusive access to that file. Now, files can also, the file that we just wrote in the example is what we call a text file. You can open it in Notepad or any other text editor, and I can actually read the contents as we wrote them. But there's also another type of file called binary files. And if you want to open a file for binary access, you can add the letter B at the end of the access mode string. Another thing about the exclusive write mode, fopen will fail if the file already exists or cannot be created. If you ask me, the read, write, append modes are pretty much what you'll need most of the time. There's also another factor you have to consider. Exclusive write mode may not be supported by the underlying system on which you're using it. So whether or not exclusive write access to a file is available also depends on what system your code is running on. Because some compilers, some OSs may not support it, do not support it. In any case, if a certain file opening mode is not available, fopen will return a null. And this is an extended version of the table I just showed you that shows you different file opening modes, including the binary modes. Obviously, opening a non-existent file for reading is always an error. That's easy to remember. Also, you need to have permission from your operating system to open a file for reading or writing. If your user account does not have access to a file and you try to access it through your program, you'll get an error again. Also, if you're out of hard disk space and you try to write to a file, that will be another error. Also, be very careful about opening a file for simple write access when all you want to do is just add new information, because what that'll do is you lose all contents that are already in the file. So careful with that.